So our next presentation is going to be by Jim Small, who's with CDW. He's going to be talking about developing IPv6 Enterprise Pilot Program. So come up and take it away.
Just let me reset my timer here. All right, good afternoon. So I want to talk about developing an enterprise pilot program. All right, so there's been a lot of great presentations today or over the past couple of days in terms of the project planning. So I'm not going to spend a lot of time on this part, but I at least want to hit a few high points. Some of this, I think, is a little bit of marketing. So I have worked in Fortune 100 companies where they actually have a dedicated lab. And if you're in a big company and you actually have a dedicated lab, then you could call your phase 1 pilot a lab. But I've also worked in smaller companies, and if you go maybe outside the Fortune 500, Fortune 1000 into more of the mid-range, and you say, I want to build this complete lab that's going to mirror production, some kind of a model office, that can be a challenging sell, right? But if you say, hey, this is something that's going to fundamentally change a lot of aspects of the network, and we need to have a pilot network that's not going to risk impacting production, I think that's a much easier sell. So I mean, depending on how you want to look at it, you can call this either one. But the idea with the first part of the pilot is we want to set up something that has as little, we want to minimize the risk to production. So my experience, I've talked to a lot of companies about V6, and that's the biggest fear is they're not comfortable with it, they don't understand all the aspects of it, they have security concerns. And so we have to give them the confidence, or if you're building it inside, you have to give the company the confidence that, hey, the way I'm doing this, there's not going to be a risk or an impact to production, right? So that way your operations team, your security team, management is not going to have heartburn about letting you get started. In terms of your pilot, it's important that you have specific goals so that there need to be measurable results. Hardware we're going to come back to in a minute. In terms of the team, so just to kind of parrot back what we've already heard the last couple days, executive sponsorship is very important, ideally from the CIO or the COO, so you don't, if there's any roadblocks, it's very helpful in terms of overcoming them. I would say for the initial pilot, you want to have kind of a small, more elite team of people that love it, the early adopters that really want to make things happen. Get your pilot up and running, and then let more people come to you to get in. Project management is also very important to keep things on track. Location. So this is usually going to be at the main location. However, I do want to point out that you don't want to just test it from the company. So for example, if you have a Verizon or a T-Mobile cell phone, the newer 4G or LTE phones already have native V6 connectivity. So that's a good thing to test. If you have Verizon MiFi, you already have native V6 access, so test it from there. Test it from your home network. So not just within the organization, you want to kind of look at it from different places. In terms of a schedule, so when you're doing a pilot, there needs to be a beginning and an end. The pilot can't go indefinitely. I would say ideally maybe no more than a quarter. There needs to be a specific amount of time and some goals that, hey, by these dates we're going to have this done, and then we're going to progress to the next phase. Testing is also really important in terms of having specific things. What are we going to test? Who's going to test it? How are we going to test it? Training. Training is another big one. What are we going to use? How are we going to train operations? How are we going to train security? How are we going to train our testers? Are we going to use websites? Are we going to use videos? Are we expecting them to read documents? Who's going to track that? Who's going to manage that? It should be tailored for the different teams, right? I mean, obviously, if I'm talking about my security team, I'm hopefully not going to give them the same material as I would give, maybe an end user that's outside of IT that's testing. Support is a big one too. So as issues are encountered, how do those issues get reported back and resolved? Communication in terms of updates, We've seen some great stuff this week in terms of having charts or graphs or things that make it easy to visibly see the progress of the pilot. All right, and then finally, so as we're closing in on the end of the pilot, we need evaluation. So back to the goals. Did we meet the goals? Was the testing successful? Do people feel like things are working well? And one other thing too that's very important to hit up front is failure. So failure is not a bad thing, it's okay. What's not okay is if you don't have a plan for it, right? So if there is an impact to production, if there's a security incident, if some part fails, but you have a well thought out response and you keep things under control, you're probably not going to have a lot of issues. But if something happens and you give management the deer in headlights look because you're totally unprepared for it, then you're in trouble, right? So those are the kinds of things you want to think about up front. Okay, hardware. So hardware is a little tricky. So my background is with Cisco equipment. And I realize there's a lot of people that run stuff besides Cisco. You might do Juniper or Brocade or somewhere else. So I want to give some general recommendations, but I also want to give specifics because there are a lot of important details. So take this for what it's worth, but I will say, if you use something else, you should be able to take this and say, hey, I need something comparable to this. So that was my thought with this. I would also say too that when you're looking at any hardware, make sure that it's USGV6 certified. Right? They've already done the work for you. You don't have to reinvent the wheel. Go and look at UNH IOL, look for USGV6 certification, that helps. Okay, so in terms of my router, you definitely want an ISRG2 series. It's got to be newer hardware. There have actually been a lot of changes, even in the past year or two. So if you have the older hardware, you're not going to necessarily have all the features. So I'll give you a specific example. With the ISRG2s, like for example the 2900 series, those run 15.2. Some of the newer features, like if I need OSPF v3 with VRF light support, this is the release I need. So the older routers won't run that. So I mention this because you really want, especially for your pilot, you want to test these newer features. For LAN switches, so you can start out with just one switch, or you can separate them for your DMZs and for the inside. I call out these specific models because for the switches, the ASICs become very important. So the older switches, unfortunately, they can run this software, but they don't have the ASICs to do all the layer 2 security features. And that's going to be a big issue because, for example, if I look at Windows, Windows is vulnerable to NDP flooding. You can actually crash all versions of Windows. So would I let that hold me up? No, but with newer hardware, I can mitigate that. On the wireless side, on the LAN side, there are current controls that will protect against those attacks. So it's important to have that. So if somebody says, oh my God, I read this article that there's all these issues with Windows, you can say, hey, I have a solution. Here's what it is. So on the Cisco side with the wireless controller, 7.2 is the release that added all these IPv6 security features. So there's some hardware there. And then you're going to want to run lots of VMs to simulate your environment. So some kind of a BV server or ideally a blade chassis. And then finally lots of laptops, of course. Okay, bonus items. So I think most companies are going to have some kind of a load balancer. So you want a load balancing solution. It was a great presentation from A10. They had a lot of things like this, but you want to pick somebody that can do the server load balancing, so they can do 6 to 6, 6 to 4, and 4 to 6. That's going to give you a lot of flexibility. So if you have things that are IPv4 only, but you need to make them accessible from the IPv6 internet, that's probably the easiest solution, and it works very well. Forward and reverse proxy. So you can use commercial products, you can use Apache and Squid, those are good. The ASR1K kind of gives you some interesting options if you want to do stateless or stateful NAT64. ACS is Cisco's AAA solution, and I mention this again because recently they added most of the IPv6 support. So going back to what Ron said, ideally you're kind of looking at management. What if I want to manage everything over v6? Like he said, you're going to need newer software to do that. So some kind of a SIM solution, ArcSight's a good one, some kind of a NetFlow collector with NetFlow v9 or flexible NetFlow, so you can do IPv6 over NetFlow. These are all very helpful things. All right, in terms of software, so key things I need, obviously I need DNS. One thing though is I also highly recommend you have something that can do DNS 6.4. So anybody who's running Linux or BSD or even Windows, if I get bind 9.8 or later, that has DNS 6.4 built in. So that's definitely something I'm going to want. For address allocation, I need something that can do DHCP and DHCPv6, file services, web services, maybe CRM. Especially important is anything on your perimeter. So if you have some kind of a content management system or other web applications, you really want to get those in the pilot because that's going to be one of the first areas you're going to want to hit. And then IPAM solution really makes life easier. We'll come back and talk about that guy more. Okay, so this might be a little hard to see in terms of everything, and it is a little busy, but I'm hoping this is good reference material. So this is just one possible approach to start out with your network. So what we're looking for is we're going to have some kind of connection to get us on the IPv6 internet. We're going to have our internet firewall. We're going to have our switches for the DMZ. I also recommend that we have a minimum of 3 DMZs. So we have an IPv4 only DMZ because there are probably going to be some things that are going to be difficult to move away from IPv4 only. We're going to have a dual stack DMZ. That's where we want to get to for now. And I also highly recommend a v6 only DMZ because I really enjoyed Ron's presentation because my experience has been you don't realize how much of a crutch IPv4 is until you get rid of it and you're v6 only. And then you really see how well you know the protocol. You're going to really learn all the subtleties. So that's really helpful. And then in terms of, I'm going to have v6 networks or maybe islands, and I'm going to have v4 networks or islands. How do I connect those together? And by the way, this is not a hypothetical thing. I can tell you from firsthand experience with my work with the utility companies that from my experience, most of smart grid is v6 only. So that's an interesting challenge. If I'm a utility company, I have IPv4 only infrastructure, I have IPv6 smart grid. So how do those guys talk? So these are some good things to work through in your pilot and figure out how are you going to make that work. In terms of the internal network, I have my switch that can do layer 2 security, and I also have wireless. So wireless is really nice because with wireless, I can have a dual stack and or a v6 only network, which is opt-in. This is great because if people want to test, if they want to be in the pilot, they can choose to join that SSID. If they have any problems, they can unjoin it. If you want to lock it down, any good wireless solution, you can restrict it to group membership. Maybe a manager has to approve that you get in the dual stack or the v6 only group. So this gives you a lot of control and a lot of flexibility. Okay, so let's go through some of the basic steps. So I am a big fan of Hurricane Electric. They have a great service. I've used it for a long time. It's really been indispensable for me learning IPv6. They also have a lot of training, a lot of great things. So the other thing that I want to echo back from what Ron said that I agree is, in general, it's going to take several attempts to get your addressing plan right. So I agree with Owen. You should try and do it like production the first time. But what usually happens is, for most people, creating a complete enterprise addressing plan is not something they do every day. There are some people that do that a lot, but not the average person. So when you're doing that, it's going to take some practice. So the great thing about starting with Hurricane Electric is that gives you the practice. It gives you the time to try something out. How does it work? How does it scale out? How manageable is it? How operationally simple is it to maintain? And this practice is vital because I can tell you consistently, I have studied a lot of companies that have deployed v6, and very consistently I've heard the same thing that Ron said, that it takes at least 3 tries to get your addressing plan right, and often more. So you need to start getting that practice. Okay, so some guidelines, and actually I was talking to Owen and Ed, and they actually changed my tune a little bit on this, so I have to make some slight adjustments. So for a site, I'm going to start with a /48 like we discussed. Now, I'll come back to some specifics on this. I'm going to have one /64 for loopbacks. That's more than I'll ever need. Each loopback will be a /128, so this is pretty much everybody agrees. Also, I'm not advocating using them, but as a best practice, you should set aside 1/256 of your address space for translation services. So out of a /48, this would be a /56. So the point that I would say there isn't consensus, because I've actually been following the ITF working groups for the past couple of years on this, is on a point-to-point network. So on a point-to-point network, should I use a /64? Should I use a /127? Should I use a /126? Should I use something else? So I have kind of been a fan of a /126, but Ed pointed out to me that if you want to add some addresses or change something or maybe use some kind of a new technology, if you do use a /126 or 127, you're pretty limited. So even if you are going to do that, you probably at least want to reserve or consider reserving a /64 or just use a /64 to begin with. So there are definitely some different opinions on that, but probably the safest bet for now is at least to reserve a /64 if you're going to use a smaller one for a point-to-point. I will say, though, that one thing I am a very firm believer in is, other than for a loopback and a point-to-point, you should never use anything than a /64. So I strongly disagree with anybody who says, you know, we should use a /120 or something because of this or that. In modern equipment, to the best of my knowledge, there are good answers for the security issues with NDP flooding. You should be looking at that and not trying to come up with arbitrary subnet sizes. I will also say that Jeff Doyle had a great point that if you look in terms of efficiency, because there's 18 quintillion nodes per subnet. I mean, isn't that inefficient if I'm only going to use a couple thousand? But if you look, if I have a couple thousand per /64 versus if I try and be more efficient and have like maybe 10 or 100 or something like that, they're both a fraction of 1%. I mean, there's no difference. And I can also tell you from teaching for almost 10 years that one of the hardest things people struggle with is subnetting. And you know, for us in the field, it's not a big deal, but remember, we have our help desk, we have level 1 and 2 support. So if we can make it easier for them and for operations, that's a good thing. All right, so here's a simple example of an addressing plan. And you can, you know, for your pilot, you can use a spreadsheet. And the idea with this is we're going to stick to the nibble boundaries. I think there's a lot of wisdom in that. And in terms of going down this, so let's say we get 2001 DB8 Babe. And I'm thinking Babe like my baby at home. So, because we're just getting started, right? And if I look at this, so the 13th digit is what I would call my place in network. And I can increment that on nibble boundaries, and this is a great start. You know, you might end up changing it or tweaking it, but it's a good place to start. So the first network, the 0, I'm going to reserve that for management. And then under that, the first 64 under that, I'll reserve that for my loopback networks. And then I'll increment it, right? And I know a lot of people that wish they could do something like this in IPv4, but there really wasn't enough address space. But now I can have a nice plan, right? Each area in my network has its own number. That gives me 16 locations, which generally is enough. And then my last one, I'm going to reserve for translation or special purposes, and then the FF, I'm going to reserve for translation services. So this gives me a lot of flexibility. I can do things like mapping VLANs to those. So there are some pros and cons, right? It's kind of a balance. I mean, if I do things like mapping VLANs, it might make it operationally simple, but it does make it easy to enumerate. So it's kind of a balance, right? You want to get your operation, your security team together and say, you know, how are we going to balance the line between operational ease of use, you know, and keeping costs down, making it simple versus keeping it secure. So we want to balance those things out. Okay, so when I look at my prefixes, so for a simple pilot, a spreadsheet is workable. But even for a /48, which is generally the smallest size you're going to deal with, you're talking 65,000 prefixes. So a spreadsheet is, you know, is going to give you heartburn. And if we look at, if you look at people that use spreadsheets, because I'm guilty of this myself, in IPv4 for end node allocation, there's 18 quintillion possibilities per subnet, right? You're not doing that in a spreadsheet. So the closer you get to deployment, you're really going to want to look at an IPM solution to make your life easier. And then also I have a reference. There's an embedded link, or you can just Google it. There is an IPv6 subnetting best current operational practices guide. It talks about a lot of these things and gives you a lot of good information to think when you're preparing your plan. Okay, so for topology, I talked through those options and just a high level and things you want to look at. So as you're working on your pilot network, you need to work through the specifics. So static routing, especially dynamic routing, right? There's a lot of changes. So you want to play around and get comfortable. Load balancing, proxying, tunneling. Tunneling, I'll come back to this a little later on the security side. So you may or may not need it. Ideally, you won't need it. The only legitimate case I would say for a tunnel is if you have legacy equipment, some people are, you might need ISOTAP. So if you have legacy equipment, it can't do v6 in hardware, the performance is unacceptable, you might need ISOTAP in limited cases, but you need to control it. It still might be good to play with the tunneling protocols just so you understand how to detect and monitor them, but otherwise I would try and avoid. NAT2, some more words on that, and then just keep in mind that if we look at our data control and management planes, they are separate, they run in parallel. So this also takes some getting used to. Okay, so I do want to say something about NAT. There are NAT 6.6, NAT 6.4, NAT 4.6 solutions that are available, but I want to caution you in using them. So probably the best example I can think of is if I look at my grandma's network at home. If I give her a NAT device, I've pretty much made it impossible for her to make anything easily accessible from home. But if I give her native access with something like the port control protocol, then she can approve inbound access, and it makes it really easy to do a lot of things. And a lot of things that people have written off, like home health care and health monitoring, now become possible if we make it easy to access and set up. So by having a global addressing scheme that's easy to use, this is a tremendous driver for innovation. So I'm not saying you can't use NAT, but just carefully think about what you're giving up if you choose to do it. So one thing I can tell you from the operations side, I help a lot of customers that do B2B connections with overlapping networks. So when you have overlapping networks, you have to change both the source and the destination address. And maybe the engineering team can figure out how to do it, but then what about your help desk and your level 1 and 2? How easy is it for them to support that? I mean, I can tell you, they really struggle. So is that the kind of thing we want to get into? So if we can get rid of that, and then also there's some other things too that people don't talk about much. So as soon as I turn on NAT, a lot of applications I don't necessarily have application layer gateways for, so they no longer work, or they have limited functionality, or maybe I need specific version of code. There's things, if I look at WebEx, SharePoint, Skype, a lot of these protocols, there's a measurable difference where they're degraded if I run them through NAT. So again, I don't want to tell anyone, you can or you can't do something, but just make sure that you weigh all this, that you factor in what you're giving up by choosing to use it. Okay, so in terms of your lab, we talked about the infrastructure. You want to go and set up all this. I'm going to breeze past this. One thing I do want to point out that I've seen cause some issues for people is DNS. So when I look at IPv6 or IPv4, DNS doesn't really care. DNS just sees IP as a transport. So what's different is the actual records, right? A or quad A. So the thing is, I don't need IPv6 to get a quad A record, right? Right now, if you look on the network and you do an NS lookup or a host or a dig on google.com, even though you have a v4 only connection, you're going to get a quad A record and IPv6 address back for Google. Right? You won't try and use it because of RFC 3484, because you don't actually have a working v6 address, most likely, but you will get that quad A record. So it's important to be aware of that when I put those quad A records in, those are not limited to IPv6 only, because I've seen that burn some people. So just keep that in mind. Maybe for your pilot, you want a separate DNS server. You just want to be aware of that, because if you start rolling out IPv6 and you only have a partial rollout, you can cause some painful problems. You also want dynamic DNS. So as your clients are getting addressing, it's really helpful if they register back to the DNS server. DHCP I'm going to come back to a second. And one other thing I want to point out is, so WINS and NetBIOS are v4 protocols only. And most people think that they don't use these, but I can tell you that a lot of people are surprised and find out that there still are subtle dependencies with some of their older applications with WINS and NetBIOS. So these guys don't exist in v6, and nor does Microsoft want them to. So just keep in mind that some of these things change. You want to look for any dependencies and eliminate them. Okay, so in terms of addressing, I just wanted to share some thoughts. So especially talk about specific things. So when I work with people and they start rolling out v6, there's a lot of things that surprise them. So one thing that surprises people from what I've seen is that in IPv4, if I do a static address, it's static, right? And that's it, and I just have that address. But the surprising thing is in IPv6, if I configure a static address, I still get a Slack address. And if stateful DHCPv6 is configured, I still get a stateful DHCPv6 address, right? So I still get all those addresses. So now I just went to maybe 3 to 6 addresses depending on my setup. So if you want to use static addresses, you actually have to turn the Slack functionality off. So this is one thing to consider. I will also say that in the v4 world, most people do everything statically, but I would say that's something you at least want to consider revisiting with v6. So one thing with static is I can look at a static address where I still get the gateway from NDP or from neighbor discovery. That's a possibility. In terms of Slack or stateless address auto configuration, so I have a couple options. So I believe by default with Ubuntu, it supports RDNSS, which is in my router advertisement, I can get my DNS information, but by default, it doesn't support stateless DHCPv6. That could have changed. So there might be a few corner cases where you want to look at that option. Although I will say that with RDNSS, it's a relatively new RFC, I think it's 6106, and a lot of stuff doesn't have support for it, but just something to be aware of. Normally with Slack though, Slack is just going to give me an address and a gateway. It's not going to give me all the parameters I need like DNS. So usually what I want to do is I want to do stateless DHCPv6 where Slack provides me my prefix, but I'm still using a DHCPv6 server to get my parameters. Things like DNS, SIP, NTP, information like that. Normally, I would say ideally for an enterprise, I really want to use stateful DHCPv6. So this is really more what everybody's used to with IPv4 DHCP, where I get all the addressing and all the information from the DHCPv6 server. And that's probably where most people want to go. There's a couple things. So one, even if I'm using that, I still have to have Slack for my default gateway. Right now, DHCPv6 does not supply that default gateway. So I can't kill Slack. The other challenge is there are some popular operating systems that unfortunately do not support DHCPv6. So Android is probably the biggest offender. So unfortunately, Android, if you want to use it, you have to have IPv4 or statically well, you can't statically configure. You basically have to have IPv4 and DNS over that. So hopefully that's going to change in the not too distant future, but for now that's a reality. So that kind of gives you a problem. For your wired networks, you should be able to go all stateful DHCP6, and it shouldn't be a big deal. However, for wireless, that's a challenge, because if I set up my wireless SSID with stateful DHCPv6, what do I do with Android clients? You know, so if I'm running dual stack, it's still okay, but if I'm kind of thinking in the future, you know, that's going to provide some challenges. So the best thing I can think of is there are solutions like, for example, Cisco has something called ICE, where I can do dynamic VLAN assignment. So when somebody joins the SSID, I can profile the device type, and I can say, okay, if you're, you know, Apple iOS or Windows or OS 10 or something like that, then I'm going to dump you in this VLAN that does stateful DHCPv6, and if you're other, then I put you in this other VLAN that does Slack. So there are some options, but these are the kinds of things that you want to work through in terms of how am I going to deal with that, and what do I have to support. All right, and so in terms of when you're looking at the DMZs, so this is somewhat my personal opinion, but this is what I would suggest in terms of how you look at deploying stuff. So everybody would agree where you want to get to is dual stack. That's really the end goal. There will be some cases where that's a challenge. So the next most desirable option would be server load balancing, right? So that's actually a very effective option, works very well. If for some reason you can't do either of those, you could also look at a reverse proxy. So the drawback of a reverse proxy is the proxy has to actually understand the protocol, right? So I'm limited to maybe, you know, HTTP, HTTPS, a few other ones. For example, I'm not going to do UC over, you know, through a proxy. It's not going to happen. So it's possible, but it's going to be much more limiting than a load balancer will. And then finally, I can also use NAT6.4, but I would discourage this. So this is doable. There's two big issues with NAT6.4. So, just besides the fact that it's complex, the first issue is that v4 and v6, IPv6 is not IPv4 version 2, right? I mean, just to state the obvious. The fragmentation in IPv6 is totally different from IPv4. The minimum MTU is different. So if you do NAT 6.4, where you're almost pretending that they're similar protocols even though they're not, you can get some really weird, very difficult to troubleshoot path MTU problems. So that's issue number one. The other issue is going back to the overlapping NAT, right? Most people, in my experience, have a hard time with overlap NAT, where I have to rewrite the source and the destination address. But if we look at NAT 6.4, that's the default, right? Because we're going from v4 to v6. So that means we have to rewrite both the source and the destination address in both directions. And remember that v6 and v4 are parallel data planes. So that means I have to ensure symmetry. So that gets into some really interesting problems I've run into. Like, for example, let's say a server has multiple addresses. So maybe in this direction it works, but then in the opposite direction the server picks the wrong address, and then it doesn't work coming back. So that there's all kinds of issues like that. I mean, can you make it work? You can make it work, but it gets into, it's hard. And you can have some difficult issues. So it is good in some corner cases, but as a general rule, I would definitely try to avoid it. All right, and then for your internal network, so again, where we want to get to is dual stack. So we have native access all the way out to the internet. We also, again, we have the option of a proxy. Again, the limitation with the proxy being that I have limited protocol support. Tunneling is possible, again, with the caveats I gave earlier. And I will say, that, so the place that you want to use stateful NAT 6.4 is for a v6 only network. So for example, if I look at T-Mobile in the US, that's how they're doing their 4G network. It's actually NAT 6.4. So this is a great solution for your v6 only network. That's really what it was designed for. And I would try to avoid using it in other cases. All right, so I've heard some people talking, and I wanted to give some specific examples of what's actually different. So one thing is, everybody talks about, hey, ARP is gone and it's been replaced by NDP, and it's easy, right? And it sounds good, but the thing is, unless you run v6 only, you don't realize it's just built into muscle memory. So when you're running your v6 only network and you're like, okay, there's some kind of a problem, let me look at my MAC address table. And you try and dump your ARP table and there's nothing there because it's v6 only, right? And then you're like, oh yeah, ARP is gone in IPv6. So this is really one of the big benefits of a pilot is actually getting the operational familiarity, right? Is I need to actually get comfortable with kind of like where Scott was saying, where this is just instinctive. I just instinctively know how to walk through the protocol to troubleshoot things because it's not radically different, but there's a lot of subtle differences, so I need to get comfortable with those differences. Also in terms of the ships in the night, so this one is hard, and what's blurring the line is, so if we look at the newer firewalls, they have what's called a unified policy, where they combined IPv4 and IPv6. And I like that. I think that's a good thing. But it's also blurring the issue because even though it's making it appear like a unified policy, it isn't. v4 and v6 are still parallel data planes. They still run completely independently of each other. So for example, my router that's locked down with ACLs to control management plane access, as soon as I put an IPv6 address on that management plane, if I have routing and I didn't apply an ACL, it's open to the global internet. Right? Because I just flipped it on. And those IPv4 ACLs are totally irrelevant because it's a parallel data plane. So I mean, this is kind of obvious, right? It's not a surprise when I'm telling you, but you have to remember this when you're doing it. You have to make sure that you're methodical about, hey, are the controls, the filters, the things I have in place for v4, am I also putting equivalent controls in place for v6? All right, and just, so this is a little small, it's more reference material, but again, just to kind of make it real, these are some of the things that change. And this is really what's the most important thing about a pilot is what actually changes. So for example, if I look at iOS, anything with IP in it is gonna change because IP really is code for IPv4, right? So if I look at my QoS, all my QoS commands with IP, those are IPv4 QoS policies, they have to change. Verse are an awesome concept. but they're usually defined as IPVerf name. Again, that changes because IPVerf is a v4 only verf. Right now I have to do verf definition. The other thing you'll notice is when you go to the multi-address family commands, a lot of times you have to explicitly activate them. So when I define just a general verf, if I don't activate an address family, I can't use it. So if I want to do dual stack, I have to explicitly activate v4 and v6. So not hard, but these are the things that you want to get comfortable with in your pilot. Other subtle things, you might go to turn on HSRP and it will squawk that it won't work because it has to be HSRP version 2, so you have to say standby version 2 to get it to work. NTP has to be version 4. So there's just, again, not hard, but just lots of subtle changes. Okay, so I wanted to give just some quick examples just to give you a view. So on the left here, I have my IPv4 only setup. On the right, I have a IPv6 only setup. So it's close, but there's a few differences in terms of how it works. So I have to get used to this. So one major limitation of the method on the right is it doesn't support verfs. Right? Verfs are really popular in larger enterprises where you can virtualize your routing table. So if I want to do that, and really I would argue the way that I want to do this is I want to get away from address family specific things and I want to go to a multi-address family setup. So in the multi-address family setup, rather than treating EIGRP as, there's the v4 setup and the v6 setup, I'd rather have a multi-address family setup where everything is in that one instance. The other advantage of this is you have to do it this way if you want verf support for v6. So this is newer. It runs on most things, but you will need newer code. So these are the kinds of things you want to look through. Same with OSPF. So OSPF is a little more challenged. Really, all of the other protocols, the EGPs and IGPs, were more address independent. I guess you could kind of argue about RIP, but RIP is pretty easy to extend to anything. Unfortunately, OSPF version 2 is truly an IPv4 only protocol. So that had to be completely rewritten. So there are a lot of subtle changes. We don't have time to get into them now. But OSPF version 3 is a significant difference. So there are subtle differences in terms of how things work. So this is, if you're running OSPF, you want to get used to that, right? So, and again, kind of contrasting them. Also, just like with EIGRP, if I run the setup on the right, I don't have verf support. So unfortunately, with OSPF, the story isn't quite as good. So I do have a multi-address family option. This is very, very new. So this just came out in 15.2.4 MNS. So I mean, it's almost hot off the press. So to run a multi-address family where I have verfs, this is what I need. And that's going back to why I said you want some of the newer equipment. This is why. I will say though that this is futuristic. Because if I look at my multi-layer switches, they still can't do this yet. I mean, it'll come in time. I will also say too, being a pragmatist, OSPF version 2 is bulletproof. OSPF version 3 and multi-protocol address family OSPF version 3 is much newer, right? It's not as field proven, so it will take time. But I would argue that if you're gonna run OSPF, eventually this is where you wanna get to, because I don't wanna have all these separate instances. I really wanna go more towards a multi-address family setup. All right, and then BGP, this is a super, super simple example. I mean, obviously you wouldn't do it like this, but just to illustrate the point. Fortunately with BGP, it's been multi-protocol for a long time. So one thing I want to point out is if we look at that no BGP default IPv4 unicast, this is a very important option. So by default, the short version is there's a lot of IPv4 dependencies, and I have to turn those off. And if you refer to this link at the bottom, it's still in draft, but it has some good ideas. Here's the idea. The idea is that when I'm running multi-protocol BGP, I want my v4 and my v6 session, I want those independent, right? So if I have a v4 path failure, I don't want it to impact my v6 setup and vice versa. So I want to configure this in such a way that they're pretty much independent. Because you can run all of your prefixes for both address families over one session, either v4 or v6, but you don't want to do it that way because if you do and you have a single point of failure, right? You want to make these things parallel. All right, so I have a couple of brief notes on security. I mean, this is easily a 2 or 3 hour talk, but I just wanted to give some highlights. So in terms of, you know, Joe alluded to this, that once you turn V6 on, you start getting comfortable with it, you start getting comfortable with the tunneling mechanisms, you will often be surprised to discover that it's already running on your network and you just didn't know about it. So what I wanted to show here, I mean, obviously you're going to see the V6 stuff, but I just want to point out that for tunneling and encapsulated versions, these are the most popular ones. So these are the things you want to make sure you understand all these protocols, at least at a basic level. How do they work? I like Scott's suggestion, fire up Wireshark. Look at them. You know, what's the setup look like? What's the traffic flow look like? Can my IDS and IPS in my SIM, can they actually detect and respond to it? You know, do I actually want this? In most cases, I would say no. There might be some exceptions, but you want to be clear on this. So just encapsulation, this IPv4, that's actually protocol 41. So most of my tunneling mechanisms where I'm running V6 over V4, I'm tunneling through IPv4 protocol 41. I can also use GRE. GRE doesn't necessarily imply IPv6 tunneling, but again, it's something you want to watch. Teredo is Microsoft's. Moredo's the open source version. The idea of this guy is if I'm on an IPv4 only network and behind a NAT gateway, this allows me to tunnel through it. Teredo, though, is, I would say it's pretty undesirable because of it doesn't have good performance characteristics and it's a security nightmare. The middle two, TSP and AYAYA, these are basically tunnel setup protocols. So if I only have a V4 address, for example, on this wireless SSID, and I need to get on the V6 internet, I can use a tunnel setup protocol. It's almost like an unencrypted VPN to get a native V6 address. So it's very useful for testing, but I don't know if you necessarily want it in your enterprise network. The relay, so if 6 to 4, I'm not going to go through all this, but that's what it uses. That's another thing to watch. Obviously, I can wrap it in SSL or TLS. The ether type is different. So if I look at IPv4, it's an ether type of 0x800. If I look at IPv6, it's 860D. That can be useful if I have specific cases where I want to block it with equipment that doesn't understand V6. I at least have the option at the Ethernet layer. And then finally, I talked about what you have to watch with DNS. So again, these are just things that you want to make sure you're aware of and you can monitor. All right, so this is, I apologize, this is a bit of an eye chart. I just wanted to throw it out there. I have really been beaten down with security issues, so I just like to point out that if you look at the security issues, there are good answers. So going through all these, I mean, like I said, I mean, this is probably several presentations, but there are solutions, right? So for example, if I look at all the stuff I talked about where what if somebody pretends like they're a router? What if somebody's running Windows Vista with ICS on and they have a broadband connection and they're gonna, you know, hijack all my computers? And in fact, kind of a quick little story, the way I got into IPv6 is I went to one of Eric Vank's presentations at Networkers, and he actually demonstrated setting up something like ICS, where on his MacBook, he basically set up a V6 connection through a cellular connection or something like that, and then he advertised an array out over the local wireless. And then everybody in the room proceeded to join his network, and he demonstrated doing a live man-in-the-middle attack. And I was like, oh. So that's what can happen if you don't have good controls in place, and that's actually what got me really interested in that. So these are the kinds of things you can look at. You know, so I have things like DHCP-v6 guard, which can protect against DHCP-v6 spoofing. I have a whole bunch of stuff for NDP inspection and protection. So I can't get into all of it, but I just want to point out that for the flooding and all the various kinds of attacks, there are some pretty good options to look into, just so you're aware of it. One other thing I like to point out is I've heard a lot about the DAT attacks, the duplicate address detection, where somebody will just say, whatever you ask for, no, you can't use it. That's actually pretty easy to beat. So if my switch supports MLD snooping, so that's IGMP snooping for V6, and I turn that on, that makes it very hard to do that DAT attack, because when I do DAT, I send it to the solicited node multicast address, and it's going to be different for each host. Right, so if I take away where multicast gets flooded to all the ports with MLD snooping, that makes it very hard to do that attack. So MLD actually becomes a security feature. So if you look at these features, there are a lot of good options. And here, This is why I specifically recommended that hardware. There are a lot of things. So unfortunately, I can't hit this in this presentation. I will say if you're interested, so Eric Vank at Networkers did an awesome presentation on this. You can go to SiscoLive365.com and see it for free. And then also Ivan Pepelniak, in tandem with Eric, did a great session that's relatively cheap, again, that you can look at to go through a lot of these features in detail, or you can just read the documentation. Okay, access control. So this is a pet peeve of mine, so I actually threw up the ones for v4 too. So this is obviously very, very simplistic. We can get more detailed, but at a minimum for v6 and really for v4 too, I have to allow some ICMP traffic. So this is a common mistake. If you block all ICMP v6 traffic, you will break IPv6. It will not function at all. So it's very important that when you set up your security controls for your firewalls, routers, and switches, you need to have access controls that allow IPv6 to function. So this is super basic. This has been mentioned before. NIST Special Publication 800-119 is fabulous. It's free. You can download it. It does a great walkthrough of IPv4 versus IPv6, and it's the best annotation of guides to IEEE and IETF documents I've ever seen. It's absolutely fabulous. And in this specific section mentioned here, it goes through ICMP and it has a chart. Here's what you need to allow for transit. Here's what you need to allow for local traffic. And it actually breaks all that down. There's also an RFC. So there's actually a pre-done table that you can just look at, and it's all been done for you. So please make sure that you take the time to look at that before you set up your ACLs. Another common mistake, so on my routers and switches, I might set up an IPv6 ACL. So whenever I do an IPv6 access control on Cisco devices, implicit at the end, it allows neighbor discovery, right? The neighbor solicitation, neighbor advertisement. So as soon as I put an explicit deny any at the end, I block that. So if I don't explicitly allow those neighbor discovery subprotocols, I'm going to break. This is basically the replacement for ARP, right? So if I block these protocols, then as soon as my neighbor cache times out, I can't talk to anything because I can't discover anything's MAC address, right? So this is a common gotcha. And then I do a little bit of security stuff too, so I just wanted to throw in a couple of plugs for some things. So I have frequently heard, if only I could do it over again, I wish I could do this, I wish I could do that. So with the pilot, you have a chance to really take a look at your network again. All the things that you've wanted to do, now you actually have a chance to do it right. I mean, this is really a fabulous opportunity. So there's a lot of little things that I just want to point out, and some of these things do actually help with IPv6. So if you're using IPsec, you should look at using IPv2 and IPsec version 3, right? These are much better. The original version of IPsec and IPv1 have actually some security flaws they're just built into the protocol. You can't fix them. But this solution has been out for quite a while. It does require a little bit of newer code, but it actually works great. I've deployed it in production in large networks. It works great. It's not hard. In fact, there's a Cisco podcast, Attack Security Podcast, where they go over IPv2, and it was awesome. All of Cisco, the TAC and the engineering team, the developers, all worked together to make IPv2, instead of all these different types of IPsec, there's one type. The debugs are very easy to understand, and it's designed to be easy to use and support. It's really awesome. When I was setting up a fairly complex IPsec setup using IPv2, and I couldn't get some of the stuff working because I was using VRFs, and I turned on the debugs, I mean, the debug would actually say, no key in this VRF, or, I mean, it would almost verbatim tell you what you have to do. So there are a lot of nice things that are more secure and will make your life easier. You just got to look at them. Another thing that kind of cracks me up, I deal with financial services. I see a lot of companies that when they're setting up IPsec, they use AES 256, but then their HMAC is MD5 and their Diffie-Hellman group is group 2, right? So that's very bad. So really all three are bad. You don't really need AES 256. It's ridiculous overkill. So really you need just AES. Rindell by itself is fine. And you should be using ideally SHA-2 or at least SHA-1. MD5 has been broken for a long time. It is not secure. Diffie-Hellman group. Diffie-Hellman group 14 is only 2,048 bits. That's the bare minimum. So I cringe when I see people using group 2. So now's the time to revisit this stuff. As you're migrating stuff to v6, do it right. Anti-spoofing, this is another one that I commonly hear, oh, I'd like to do it, but now that I'm in production, it's too late. I mean, here's your chance. You know, now's your chance to roll it out. Another one, Team Cumry, they have their Bogon list, which you can actually get from BGP. This is awesome. So now you have the chance to actually set that up and play with it. DNSSEC is another one. So you have all these great features available to you. Now is the time to take a little bit of time, and I'm telling you, a lot of this stuff, the design is better. It's actually easier to use and support. It just takes a little bit of time to set it up. Okay, so as we're winding down with the phase 1 and we're moving more into phase 2, and again, this is kind of a busy diagram. Hopefully it's a reference. This is more of an overlay setup. So the idea with this is phase 1 was more out of band. Phase 2, this is going to be an overlay into my production network. And there are a lot of different ways you can do it. I already have gotten feedback. Some people don't like this way. There's lots of different ways. This is just one. So, you know, hopefully maybe take the ideas you like, the ideas you don't like, throw them away. But the idea with this is I start with an overlay, which is almost parallel. You know, the customers I've working with, I mean, I'm only one person, right? So that's only a small set. A lot of them have heartburn about running IPv6 over anything in production until they're really confident about it. So one way around that is I can kind of do parallel setup where I use VLANs or different things to isolate it. I mean, so the device itself is still running IPv6. I haven't gotten as much pushback on that as long as it's somewhat isolated. Now, if you can run dual stack from the start and you don't have to separate it out like this, that's great. I mean, that would definitely be a better way to go. So I just point out that there are options for you to consider. When I look at this, I don't want to turn away so I lose the mic, but if the other thing too that's a challenge is we've heard a lot of talk about this, security, SecOps. You know, they're going to have concerns they have to ramp up, and there's also a lot of tools. Right, I have my IDS IPS, I have my web application firewall, I have my email and web security gateways, I have my SIM. You know, I have all these different solutions that I use that I depend on for security. How do they deal with v6? So this is the great thing about an overlay. Now I can start running this through. So if my WAF doesn't support v6, maybe I don't go through it right away. I work with the vendor, find out what the roadmap is. But if my IPS does, I can. So I can kind of selectively start running this through, and where I want to get to the point where everything is running through my standard perimeter. And I'm confident that if I look at all of my security, all of my controls, all of my management tools, they are all fully operational. So this gives you time to phase that in. Because if you try and do all that at once, that's a really big undertaking. And it's a good way to overwhelm your security team. So this gives you the option to phase that in. And then, you know, with the pilot, you can expand out as necessary. You don't want to get too much further. Once you get comfortable, you want to look at moving this into production. And as far as the deployment, I mean, that's another talk. But I'm hoping, when you look at this, I'm hoping this gives you some useful ideas and concrete things that you can do to actually get your pilot started and help the organization that you work for, or the organizations that you work with, that you can take this and this will be a helpful tool in terms of getting them to a dual stack state. All right, and this is pretty much just a summary of what I just said. One other thing, just to point out, if you don't do it in the initial phase, you also want to run BGP. So most sizable companies are running BGP. They're multi-homed or some kind of variant. So you also want to add that to your overlay. Again, through Hurricane Electric, they do full BGP peering. I mean, they have a great setup. So there's no reason you can't do that too. So again, even with BGP, you know, you can get comfortable with your bogons, with your prefix filtering, route maps. All of those things can be well tested. You can play around until you're supremely confident that you're ready to go. Okay, and then a few parting thoughts. So IPv6 is a big topic, and you know, I know a lot of people have done this for a long time, so we kind of forget this. But to put this in perspective, we're talking about the global underpinnings of communication. So my experience has been, when we're talking about this, try and be specific. You know, we don't have to talk about everything. We can start with the IPv6 internet. We can start with specific use cases. And also, when you're looking at the pilot, there's a lot of nice new things, like multicast is vastly improved in IPv6. But you don't necessarily have to do it on day one. You can work up to that. You want to have an incremental deployment. Don't try and turn on everything, all the new layer 2 security features, all of the new IP. Don't try and do that all at once. Phase it in, learn the features, take your time. The other key thing is, really from the beginning, is make sure you keep your executive sponsor involved, make sure you keep your team involved. You have to have good communication, and you have to stay on top of issues. When there's issues, they need to be dealt with. If you deal with the issues in a timely manner, then you're going to give people confidence, and they're going to want to move forward with it. I will also say, too, because I know I've heard mixed reviews about, some people have had some skepticism, but my experience is, I mean, once you get people on board, once you get them thinking about what they can do with IPv6, they get pretty excited. I mean, even like if you talk to healthcare, if you talk to a healthcare company, I work with some healthcare companies, you start talking about home medicine, telemedicine, things that are not possible with v4 because of NAT. But with v6, I can do that. If I have, things like a pill dispenser that's going to remind people to take their medication, these are ways that I can reduce costs. These are innovations that can differentiate me and provide better services. So there are a lot of cool things you can look at, and we want to focus on that. I guess one other thing too, just as I'm kind of winding down, is one thing I didn't do in this presentation is I didn't talk about why. But why is a really important question. So in my opinion, if you can't answer with confidence to a technical or a completely non-technical person why they should deploy IPv6, if you can't answer that question, you're not ready for this. There's lots of great material. I'll plug my blog posts. I wrote about that just to help everybody, where I talk about a lot of this stuff. There's a lot more stuff, but make sure that you can confidently answer the why question. Because if you go to your executive team, and they're going to ask that, right? Why should we do it? If you can't give them a good answer, if you can't tell them how it's going to help them in their industry, how it's going to help with technology, why should they do it? So I'm kind of stating the obvious, but make sure you have a good answer for that. All right, and then this has also, I think, been covered pretty well. I think that the biggest thing here with the cost is the sooner you get on board, the sooner you start getting everything inventoried, figuring out what you need, the cheaper it's going to be. The more you procrastinate, the more you rush it out, then you're going to be looking at rip and replace. So I've also had really good success with actually showing people, well, hey, let's go look at Gartner. They're saying that you have to deploy by 2014. So, okay, and you trust Gartner, right? So, okay, so let's think about that. So let's figure it out. So if you have to be online by 2014, how long is that going to take you to be ready? And you kind of walk them through the thought process, and they're like, oh, actually, it's going to take a long time. Yeah, so it's time to get started. And I've also gotten a lot of pushback on, hey, but if I look at this application, it doesn't work over v6 or this and that. You know what? I say that's a positive thing. If I look at this and I find stuff that doesn't support v6, I can use that as a tactic to negotiate a better price with the vendor. So that doesn't have to be a negative thing. Everything can be a positive if you turn it in terms of cost avoidance. All right, and then I have a bunch more stuff in the appendix just as a reference that hopefully it helps. And I also wanted to mention, so this is my book list. If you ask nicely, I'm sure that Sylvia or Scott might be willing to sign the books if you have them. But these are all great books, and I really think that if you're leading the deployment, if you're leading the architecture, you need to know this stuff. Because you need to have the answers to help your team, to help your company move forward. All right, and then the last thing is, I just want to blog this real quick. So I had the privilege of speaking on Packet Pushers, which I think is a fabulous vendor-neutral podcast. And as part of that, I started writing blog entries, including why IPv6. So if you have some questions or you have some suggestions, please, head over there, check it out. There's a lot of great material. And this is something that's meant to be vendor agnostic and just to help everybody. Hey, how can we help deploy IPv6? How can we help educate people and move things forward? So with that, I'd be happy to take any questions if there are any. It can. Never seen it crash it? Okay, sure, we can talk. Yes, sir. The presentation is actually posted on the GoGo website. It's already there. Bruce already thought of it. Any other questions? All right, thank you very much.